Hey, we're here with quadratic formula back again. So remember that standard form is ax squared plus bx plus c is equal to 0. Remember that the other standard form would look like this, where this 0 is not there, and it's f of x or y, essentially. So that's another part of the standard form for quadratics. Remember, you want to identify A, B, and C and carefully plug those into the quadratic formula. I would be very, very careful of putting in the discriminant. We talked about that, this being the discriminant first, and that's going to kind of let you know, if you can continue on. And we're going to look and see what that looks like as far as how that's going to look in a quadratic equation or a formula. So here we have 3n squared minus 2n is equal to 6. I need to move 6 over to the left side because I need 0 on the right side. So now I have my equation. And so here, my A is 3, my B is negative 2, and my C is negative 6. And so when I plug that into my quadratic formula, I am going to have negative 2 plus or minus the square root of negative 2 squared minus 4 times 3 times negative 6. All of that divided by 2 times 3. So now at this point, I plug in my discriminant first. I plug in this into the calculator first, and then go from there. So I have x. I'm kind of coming over here now. X is equal to 2 plus or minus the square root of 76. 76. That's what I got from my discriminant. So since it's positive, I know that there are going to be solutions. Divided by 6. So now here are my two equations that I end up with. Here I end up with x is equal to 2 plus the square root of 76 and divided by 6. And then x is equal to 2 minus the square root of 76 divided by 6. Running out of room. And so then I get 1.79 here. And then I get negative 1.12. So these two are my solutions here. And that means my x-intercepts, zeros, roots, solutions are these two answers. All right, let's look at the next example here, example 2. You could, if you wanted to, move negative x, or you can move x squared to the other side. I always like to keep my x squared term, my a, I like to keep it positive just for my personal preference. So I'm going to come over here, I'm going to subtract x and add 8. I'm going to do the opposite of both of those on each side. Remember, it's still equal sign. You have to do it to both sides. I do it in one step. You could move x over, then move 8 if you would like to. It essentially ends up being the same thing. Essentially, it is the same thing. Minus x plus 8 is equal to 0. All right, and so now my A is 1, B is negative 1, and C is positive 8. I will tell you, anytime you have the same sign for A and C, just be careful. That's all I'm going to say. Kind of be prepared for something to get kind of funky. That's not always. I'm just saying to be prepared for that. So for my quadratic formula, I have a negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times 8 divided by 2 times 1. Now here's why, if A and C have the same sign, why this gets a little bit crazy. If one of these, if A or C has an opposite sign, it makes this minus become a plus because it's negative. That would essentially be negative 4, and you are multiplying two negatives. Well, if they're all the same sign, that sign becomes minus. When you start subtracting numbers, you have to be prepared for negative values. So that's where you need to be That's why I say just watch out. It can happen. A and C can have the same sign and your discriminant be positive. But in this case, this discriminant is not positive. So I have x is equal to 1 plus or minus the square root of negative 31 divided by 2. All right. So I can't find the square root of negative 31, not because 31 is not a perfect square, but because it's negative. I can't multiply the same number the number to itself 2 times to get me to a negative value. So it doesn't, even if that's a perfect square, even if it were 36, it still would not be viable because negative, the square root of 36 is 6. So if it were negative 36 here, negative, whatever it is, this is going to be negative 5.7. So negative 5.7 times negative 5.7, it has to give me a positive. So that's why negative values don't work. And if you were to plug it into your calculator, it says non-real answer. Okay, so at this point, that would be your answer, non-real answer, or solution. You could do solution too. So what that means, it never crosses the x-axis. That's what that means. So if you were to graph this, you would see that it is plotted way high up. It opens up. A is positive, and we're going to learn a little bit more about that. But that's what that means. All right, let's look at the next one. I am going to move my 2x squared and my 16 over. Now, yes, this is more work. It is more work, but I like A to be positive. That's just me, kind of my personal preference, but you could move 32 over. So I have 2x squared minus 16x plus 32. I do like to write it in standard form, so I like to put it in quote-unquote order. So A is 2, B is negative 16, and C is 32. All right, so now let's look and see what we get here with this solution. So I have x is equal to negative 17 plus or minus the square root of negative 16 squared minus 4 times 2 times 32 divided by 2 times 2. When I go to put in my discriminant, that's another reason why I like to put it in first, because it's going to help me be able to make sure that I put my answer in right. So if I get a non-real answer, if I get something funky, I know that if I did, because I put the whole thing in, that there's not some sort of error. So when I put this discriminant in, I end up with 0. So x is equal to 16 plus or minus the square root of 0 divided by 4. You can find the square root of 0 because 0 times 0 gives you 0. So essentially, whenever I have my two equations, you end up with 16 plus the square root of 0 divided by 4 and 16 minus the square root of 0 divided by 4, and you end up with the same answer. So you don't really write it twice. You only write it once. So really your solution is x equals 4. Now you're saying, what does that mean? Well, that is going to show that the minimum, I think A is positive, so the minimum is going to come down, touch the x-axis at 4, and go back up. So that's why we get one solution. So you can have two solutions like we saw in the first example. You can have no solutions essentially, or non-real solutions. And then you can have one solution. And all of those refer to the fact that we're solving basically finding the x-intercepts. That's what I have for you, a kind of sort of a refresher on all of that, showing you a little bit more quadratic formula, that discriminant, why that becomes so huge, and being able to solve all of this.